The London Eye is a famous Ferris wheel in London, England, which you see pictured on the screen in front of you. In this example, we will be looking at a passenger riding the London Eye and measuring his height as a function of time. So some dimensions, some information about the London Eye. The height of the London Eye is 135 meters, and the diameter of the wheel is 120 meters, and it takes 30 minutes to go around once. So here's the Ferris wheel. It's supposed to be a circle. And then we have the ground here. And so suppose you get onto the Ferris wheel at time 0, and then you travel along the Ferris wheel. The question is, what will your height be as a function of time? Now we'll model your height as a sinusoidal function. And we'll be using sines and cosines to figure out what the height of a passenger is as a function of the amount of time in minutes that he has been on the London Eye Ferris wheel. So since the diameter of the wheel is 120 meters, the radius is therefore 60 meters. And also, since the height is at 135 meters, so we can look at, so that's the height here, the base is 120 meters below the height, which means that the base must be 15 meters above the ground. Now, when looking at this, what's our function going to look like? Well, we start at the bottom. So we start down here at time t equals 0. And then 30 minutes later, we return to the bottom, to the base. So about 7.5 minutes in, we'll be increasing in height, and we'll be here after 7.5 minutes. Then we'll continue to increase, and we'll reach the top at 15 minutes. Then we'll start our downward portion. So this is 22.5 minutes, and then we'll reach the base again at 30 minutes. So what will this look like? Well, we start at the bottom, we go up, we reach the top, we come down, and then we reach the bottom again. So the top will be at 15 minutes. Right here will be about 7.5 minutes, 22.5, and 30. So this is approximately what the function will look like. Now the midline will be exactly right in the center. So first of all, the midline should have a height equal to the base height plus the radius. So the 60 plus the 15 gives me a midline of 75 meters. Right? So the midline in our standard trig function is going to be 75. And then the amplitude, right, is going to be 60 meters. So the amplitude measures the distance from the midline to the peaks. So the amplitude will be exactly 60 meters and the midline will be 75 meters. And then to come up with the angular frequency, we need to know the period. So recall that there's this relationship, so we have a sine or a cosine of omega times t. And we want omega times t to equal 2 pi exactly when you complete one cycle or make one revolution along the wheel. So in other words, omega times the period is going to equal 2 pi, which means that omega is equal to 2 pi over the period of 30 minutes. So therefore, omega will equal pi over 15. So omega is going to equal pi over 15, the amplitude A will equal 60, the midline B will equal 75. Now in terms of the phase shift, we can start with a sine function and do a phase shift, right? Because we want, this is basically our t-axis, and then this is basically h of t. See how I made a graph like that. But instead of using a sine, what we can actually do is use a cosine. So note that the cosine starts up here, goes down, comes up, and goes up. This is similar to a cosine, except instead of starting at +1, it's starting at -1. So it's actually the negative of a cosine. Right? So as I was saying, the regular cosine function looks like this. And so therefore, negative cosine of x looks like that. So this is negative cosine of x, whereas the first one I drew was cosine of x. So basically, the shape that we have here is exactly like negative cosine of x. So I'm just going to use the negative cosine of x instead of the sine of x, and I don't need to worry about the phase shift at all. So therefore, the height, okay, well, let's see. The midline was 75, plus the amplitude was 60, minus, so I'm using negative cosine, so I want minus 60 cosine of pi t over 15. And that is your height as a function of time. Now you can do a check. So we said that at 7.5 minutes, we were at the midline. So let's check. 7.5 over 15 is 1/2 times pi. Don't even need a calculator for this actually. 1/2 times pi is pi over 2. This would be pi over 2. So it's 75 minus 0, which is just 75. Right, so it's 75, which is the output. At 0, let's check. Cosine of 0 is 1, and 75 minus 60 is 15. So at time 0, you are indeed at height 15. When the time is 15 minutes, 15 over 15 is 1, and we have the cosine of pi. Cosine of pi is -1. So we get 75 minus -60, which is 75 plus 60, which is 135, which is the very top of the Ferris wheel. So it looks like that checks out. So the height as a function of time is just 75 minus 60 cosine pi t over 15.